My name is Jeff Pierce, and I'm here to talk about how to effectively culture a healthy culture and workflow. I am Jeff Pierce. I am an operations engineer at Remind. We are a education messaging company. We connect teachers, students, and parents. You can be found at remind.com. My email is jeff@remind101.com. My GitHub is github.com/JeffPierce. On Twitter, I am the Technomancer, note the 3. And this slide deck is available on SpeakerDeck at speakerdeck.com/Technomancer. A little bit about me. I've done stints at Apple, Rackspace, and Change.org. I am the project lead and developer at Casa. We make graphite not suck. I occasionally will blog at almostinteresting.net. Much like me, I'm only almost interesting. So, one of the speakers last year, Paul Reid, put out this great tweet that I love, and that is for cloud, DevOps, containers, microservices, serverless. Sorry, I've had 3 back surgeries. I stumble a little bit. Do echo. This tech won't fix your broken culture. And then, hey, look, you have a conference talk. So, let's talk about culture and workflow. Basically, in my view, there are 4 key points to having a healthy culture and workflow. The first is that everyone involved needs to have a sense of personal responsibility. Your code is yours. Treat it like it. You also need to choose an application architecture philosophy and stick to it. This makes sure that you have a very strong foundation for all of your new services, applications, etc. You know they're going to be built the same way, configured the same way, things of that nature. You need to make important decisions before you're under fire. I mean, who here has been rushed to make a decision and made a mistake? Show of hands. Everyone whose hand isn't up, you're lying. And then finally, as much as we would like to pave over everything, you really want to use your existing tool set whenever possible. So let's go in a little bit of detail about these 4 points. Personal responsibility. In the old world, before DevOps, you had your developers and you had an operations team. And then you get situations like this. We're fun a dev, ops problem now. Everything's on fire. So the first step in having personal responsibility is that developers need to deploy their own code. After all, you've created it, you've built it out, you should shepherd it into production. This obviously requires a strong continuous integration and continuous deployment tool chain to make sure your code is checked, it's done fast.
These products collect telemetry for the different tiers of components
And
of
I
the
am
application.
fighting with the speakers.
From the web or from the browser, from backend, middleware, infrastructure, even monitors.
Anyway.
It can process this data and correlate data.
Hello! All right, so this also requires a robust infrastructure plan that makes rolling back bad deploys easy. I'm sure you've all heard of the concept of immutable servers. Has anyone not heard this term, immutable servers? Show of hands. All right, immutable servers is a concept that says you're going to deploy the server, whether that's an Amazon AMI, a Docker container.
Discuss now what the type of data that is collected by
It
these
happens.
API products, so you understand the richness of the data that you can
I will now be completing this talk in interpretive
So on
data.
the left, you see a schematic view of the application. You see the users, you see the different clients that they use. There's the application and a dependency, in this case it's the database, the platform and the infrastructure in which the application is built. So the first type
Fortunately, I can be loud.
is outside-in monitoring. where you can check if your application
Yes,
is
you should
up or
obviously
down.
talk
And
over
these
everyone else in the
products
room.
allow you to
But immutable servers basically means that you're deploying your code and your server infrastructure as one
usually
piece.
done from where
You don't change it once it's deployed. You roll out new AMIs, new servers, things of that nature, new containers completely. You do not change something already deployed. Another thing that you have to have to instill personal responsibility is an all-hands pager. It's not just your operations team, your systems engineering, your SREs, whatever you want to call them. It's not just them fighting the fires. But to do this, since not all engineers will be familiar with all pieces of the code, this requires a very strong set of runbooks for troubleshooting. These are the things that you need to build and put in place. So that way when the pager goes off at, oh my God, in the morning, you don't have to do a whole lot of thinking. And it spreads around the pain of on-call duty. You don't want to end up in a situation where the monitors are red, the ops team is blue, someone switched up their operators, and now false is true. And it also helps to have a common architecture philosophy to make troubleshooting individual applications easier. You always want to know your logs are going to be in the same place, that the same supervisor application, whether that's systemd supervisor, something like that, is going to be running your software. So, in order to do that, you need to pick an application architecture philosophy. You need to stick with it. One of my favorites is called the 12-factor app, and this is copied directly from their site at 12factor.net. But the idea behind a 12-factor application is that you're going to use declarative formats for your setup automation. You want to minimize time and cost for new developers joining the project by doing that. You want to have a clean contract with the underlying operating system, offering maximum portability between execution environments. This means doing things like, rather than having a configuration file, you set your needed configuration as environment variables. So no matter where you deploy, it's going to look the same. The only thing that's changing is your environment variables. You don't have to worry about managing files or anything like that. Because remember, we want as few moving parts as possible. Applications built like this are suitable for deployment on modern cloud platforms, obviating the need for servers and systems administration. In today's world, especially if you are a startup and you're using Amazon, they have a ton of services that don't require you to actually run a server. Take advantage of them, because then they're dealing with that back-end BS. And then you want to minimize the divergence between development and production. You want to enable your continuous deployment for maximum agility. You want to be able to make sure that your staging environment is like your production, is like your development environment, and it's across all different regions. This is the same thing. No matter where you go, your deployment is as similar as possible to every environment. And finally, it can scale up without significant changes to tooling, architecture, or development practices, because once you have chosen this architecture, everyone in here knows that once you have a set of policies and procedures in place, it is damn near impossible to change it, whether that's because of time, the need to get out features, anything like that. If you're having to change this, you are racking up technical debt at an amazing pace. So when we pick an application architecture philosophy, whether it's 12-factor or crash-only system, or crash-only applications, things like that, look, it makes onboarding of new engineers faster. Every application in the stack is treating resources the same way. Where you deploy it, it's no matter what, it's the same sans your environment variables. This makes your tooling more portable and reusable, because the less code we have to rewrite, the better, for obvious reasons. And also makes planning for new applications and microservices a breeze. You know how your new application is going to be deployed. You know how it's going to interact with your data stores. And it makes everything a lot easier to sit down in a meeting and not have to worry about how do we architect this. You already know how. Now it's just, putting in the pieces to make your application work. So you want to make sure that when you make decisions, you aren't under fire. You're not trying to do this in the middle of emergency. You're not trying to do this during a ramp-up period. For example, working at Remind, where school messaging, the back-to-school season after summer break in the US is one of our busiest times, if not the busiest time. We don't want to make decisions on how to do things when we're all working 60-hour weeks and scrambling around trying to figure out how we're going to handle all of these new customers. So, as we had with the show of hands earlier, when you rush your planning, mistakes are made. Make sure you have plenty of time to think about how you're going to implement these things I've talked about. You want to make sure to plan your objectives on a yearly, quarterly, and per sprint basis. You need to have your long-term goal, where you want to be in a year. You need to have a quarterly plan that talks about how you're going to get there, the various steps, quarter to quarter, something measurable for the bosses. So at the end of the day, these are all business decisions. And on a per sprint basis allows you to make chunks out of the work manageable and set short-term goals that can be easily achievable. You also, as I mentioned earlier, you want to write run books to remove the amount of thought required at 3:25 in the morning and production has gone to hell. Because it happens. No matter how well something is designed, something will break. It'll be a vendor dependency, it'll be a bad push of code. You never know, but it's going to break. So make sure you have all your instructions in line so that whoever of our all hands on call rotation happens to have PagerDuty blow up their phone, you know, if it's on a Galaxy Note 7, those explode on their own. You want them to have to do as little thought as possible. There is a run book. These are the possible ways the application can break. Go down these steps. Have a clear escalation path if that fails. And then one of the big ones that a lot of companies do not do is when they are planning, is when your feature development teams are planning for a new feature or something that's going to add load to the infrastructure. DevOps and the infrastructure teams are nowhere to be found in a lot of cases. And that needs to change. DevOps and infrastructure teams need to sit in on feature planning. They need to be there from the start. So that way there's no rush. You know, you're 2 weeks out from application launch and no one's giving you the specifications of the systems that this application is supposed to run on. By sitting in early on these meetings and offering your opinions and the knowledge that you have of this tool set, because if you're a DevOps engineer, infrastructure engineer, you have a very specialized knowledge, very deep knowledge usually, of how everything works. So you'll be able to advise them that this is going to take a certain amount of time, that you need to plan for these contingencies. You need to have your run books ready. These are all things that make a minimum supportable product. Not a minimum viable one, but a minimum supportable one. Because the end goal here is to be a proactive and not a reactive department as systems engineering. I mean, who here feels that if you are a systems engineer, an infrastructure engineer, site reliability, that you find yourself being more developer support than an engineer in a lot of cases? All right, so the point here is to make sure that the split between engineering and developer support is a fair balance, because we're all smart people. We like engineering. We like building things. We like making these intricate, complex systems work. In order to do that and not just be fighting fire after fire after fire, you have to be proactive. And to get there, you have to follow these steps so you know where you're going. You have to have a plan. And then finally, you want to use existing tools whenever possible. Yes, I know they suck. I mean, God forbid you're stuck with something like CF Engine, or you're still doing things with shell scripts, or but at the end of the day, if you're using existing tools, you're reducing training. You have talent at your workplace. They have a certain set of knowledge. Try to use that as much as possible, because training is time, time is money. Requires less engineering work. If we're able to use out-of-the-box tools or tools that already exist, this is time that we as systems engineers don't have to sit there and build glue code or look at the application, see how they're going to fit together. We've already figured that out. Obviously, like I said, this saves time and money. So at the end of the day, again, these are all business decisions that need to be made. Unfortunately, in today's world, whether you like it or not, as a DevOps engineer, you must think about business. In many companies, we are a cost center, not a value provider. And because of that, we have to continually think about what we're spending, how much time it's taking. Are we standing in the way of feature deployments of items that make money for our company? So, that's all well and good. I'm sure most of you have heard much of this before in different talks. This is nothing new. But what many speakers don't go into, and what I'm hoping to go into today, is how to actually make this happen. All right? You need to be the change that you want to see. Because at the end of the day, you have to figure out how you're going to get this all in place. So, as I saw in my bio earlier, I used to work at change.org. And one thing that I definitely learned from there is how to get attention to an issue. And one of the first things you can do is build a compelling story. One of my favorite quotes is from an American politician, Rahm Emanuel, and it is, "Never waste a crisis." When something blows up, when something goes bad, when you've had one of those engineering horror stories that everyone has run into at some point in their career, and if you haven't, you will, you want to find that compelling story. You want to give a reason to say, this is going to make our lives better. If we do this, we're going to, maybe you are in a workplace where, you can only deploy your code effectively 40% of the time. You have bad builds, you have bad pushes, or your application isn't highly available, so it crashes and it's waking people up. Or because there's not a tool set in place, the systems engineering team or the DevOps engineer on a feature team is so far behind that they're holding up the release of applications, updates, things like this. These are the compelling stories that you can take to management to make the change you want to see. And it's not just management. You need to identify the key stakeholders in what you're doing. These are the engineering managers. This is your VP of technology. This is your CFO. Because again, business decisions. Once you've identified them, you need to engage them. Because, how many, again, another show of hands, how many of us in here have brought a plan like this to their boss and just got nothing back, just stonewalled? Happens to a lot of us. This is common for this industry. But you need to engage them. You need to tell this compelling story to them. You need to sell it. Because, again, I want to drive this point home. You need to make a business case for this. If you're doing this right and you're architecting your applications properly and you're enforcing these processes and policies, they don't have to be onerous. It doesn't need to be a bunch of red tape, but it needs to be a process that people follow. Because when you've made that business case, when you can go and say, this is going to save us a certain amount of money, that's hard for someone to pass up, especially if you have a sprawling AWS deployment or something like that. Saving a lot of money can act like you're bringing in as much revenue as a new product. And at that point, now you are a value add to your company. You are no longer a cost center. You are engineering. You're not developer support. And then finally, you need to actually do what you said you're going to do. You need to prototype this plan. You need to secure the time to go out, build this software, or implement this tool set. And you need to show that it works. Because at the end of the day, again, a lot of this stuff that I'm talking about, everyone here has heard before. But how many people have actually gone and put it in practice? Anyone? Very few. Prototyping your plan, like any piece of software, shows that you have a minimum viable product and a minimum supportable product. And you have to think about your infrastructure as a product. You are releasing tools to make developers' lives easier. You are setting up an infrastructure where developers can own their code from development to production, including deployment. You do all of these things, and then you have a chance of actually getting this culture shift and this workflow in place. So, you look like a room full of winners, and they ask questions. So, by all means. Mhm. The question was that a lot of this stuff works well for a cloud environment, but have I seen this work in an on-premises setting? Absolutely. A previous job I was at was running its own data center. It had a VMware stack, and sorry. Gotcha. So if you're creating software that you're actually shipping to people rather than putting online, there are definitely ways to do this. You can have statistics in your software that sends information home, learn about how your users are using it, and things of that nature. Get them to sign, get the people who are buying your software, find ones that are friendly to you, and, let them allow you to collect data from them. Give them a discount if needed. But you need to have this data available on how it will make shipping your code to an external customer easier, how they're using it, how to architect it. And a lot of this stuff can be done in-house just during your development period, except all the way up to deployment. Rather than that, you're packaging and you're shipping code. But the workflow mainly stays the same. Any other questions? Sure. Yes, if I could go back to what I was talking about on-premise. A previous company that I worked for was running their own data center. They were in the process of moving into a cloud environment, but that was slow. Their tool set made it so that only 30 to 40% of deploys were actually successful. They were putting out code to already running servers. They didn't have easy ways to roll back. They didn't have a development culture that said if a deployment is bad, stop pushing code to master. And in an environment like that, there are still ways that you can build tool chains around, because in an environment like that, no one is happy. They are ripe for change. So standing up and presenting the idea that, hey, we need to make this better, this should not be a difficult sell, because people are already working long days and having bad deployments, and code's only going out once a day or once every couple of days. And you can build these tools around things like, around a VMware environment. There's plenty of good automation tools for that. You can use things like Packer to have, to build your VMware images for you, so that you're deploying out a full image, not deploying code to an already existing virtual machine. Any other questions? All right, the gist of that question is, how do you teach an old dog new tricks? And yeah, and this is where the business case comes in, because if you're talking about a manager at that level, they've been around in the industry for a while. They know a certain way to do things. And what you're proving at this point is not so much that your way is technically better, but that your way is going to save money. It's going to make your boss look good. Because at the end of the day, that is a lot of our jobs, is to make the people managing us look good. Because when they look good, the team looks good. When the team looks good, we look good. And when we look good, we have a great career. So this is why the business case is so important. If you're trying to implement this and it's not going to save your company money, then you don't have a business case for it. You don't have a reason to put it in. You don't have a reason to change the tricks. So in a situation where you're trying to make a change like this, you really, there needs to be a reason for it. You can't just change for change's sake. Most of the days with modern tooling, with a strong architecture, with a good culture that is willing to explore new ideas, especially if you can say this is going to save us a lot of money. This is going to allow us to hire another engineer. This is going to allow us to get out code faster. Make these business cases, and it's very difficult for even a manager that's very set in their ways to pass that up. The business case is the strongest thing you can make as engineers nowadays. You have to think about the business. I believe we have time for one more question if someone has one. Mm-hmm. All right. All right. The question is, does the shipping code faster constitute a business case? And in many cases, yes, because what shipping code faster allows you to do is ship smaller chunks of code. The smaller your releases, the less likely they are to break something, and when they do break, the easier it is to roll it back. So it's very easy to make the business case that if we're able to ship code faster, we can ship code in smaller chunks, and that's going to give us less downtime, which saves money. That's going to give us the ability to work on small tests and experiments, which can uncover ways for the company to make money. And at the end of the day, if you're doing it right, you are saving developer time by having less rollbacks, so when you have to do it, they take a less amount of time. Time is money. We're engineers. We're expensive. If you're saving our time, where we get in an extra 2 or 3 hours of work a week across an entire engineering team, that's a lot of money. Depending on the size of your company, that's 5, 6, 7 figures. That's hard for any manager to turn down as long as you can prove it works. Anyway, thank you very much for having me here. Have a wonderful day.